help me out with this table? After 1 second, how far will it have traveled? Raise your hand and tell me how you know, right?
416 feet.
And how do you know that?
Because we just add 406 to 10.
Yeah, so each second we're adding 406 because there's no gravity, it's just going. Okay? So at 2 seconds, everybody.
820. Everybody, Sean. 822.
822.
Thanks, Sean. Sean, 3 seconds.
1,228.
Okay, and then I'm going to jump right up to
1,228.
1, 2, 2.
Ooh.
Okay, I'm going to jump right to the t. Someone help me out with the equation. I guess that's an expression technically for t. Yeah, Olivia.
10 plus 460.
460. So that means our equation of distance is 10 plus 406t. Now let's talk about how this is the situation. So I know it's going 406 feet per second. What's the other piece of information in my equation, and what does it mean in context? What's the other part of that equation, and what does it mean in context? The starting value of?
The distance above the ground in feet.
So where are we shooting this cannon off from? 10 feet. So we're starting 10 feet off the ground, and we're shooting. It goes 406 feet per second forever. It's never slowing down. There's no gravity, right? Theoretical. We're going to use this paired with what we know about yeeting the rock off a building to do this next part. So stay with me for this next problem. We just saw that gravity-free zone, but in the real world, this cannonball is going to have the force of gravity exerted on it. So this is the table that shows the same thing, but there's gravity. We know it's the same thing because the directions say it's the same thing. Also, if it's the same thing, it had the same starting point. Does it have the same starting point?
Yes.
And it does actually have the same 406 feet per second, but why isn't it at 406 feet after 1 second? Sean?
Because it's like 16 t, so it'll be minus 16.
Whoa. Okay, you jumped 3 steps ahead of me there. But why is it less? More general. Gravity's pulling on it. When does gravity start pulling on it? As soon as it leaves the tube, right away, right? Gravity's pulling on it. So it's not just going 406 forever. It's actually got to be slowing down. So you're going to run through 1, 2, 3 here. Well, you already have the table. You're gonna compare the data values and make some either assumptions or make some observations. Then you're going to graph them both and compare the graphs. And after all that, you're going to try to write the equation of the situation with gravity. Don't be afraid to look back at the last lesson if you need to for that gravity piece. All right, let's get going. So I'm not going to draw these whole graphs, but if you graph the first one, it was like something like that, right? And if you graph the second one, it was really similar, and then all of a sudden it started kind of doing kind of like that. I don't have the exact points, but that's generally how the graphs look. Now, when you looked at the tables, what are some observations you made looking at the tables? Who can give me some? What's an observation from looking at the values? Riley, you got one?
Well, we can't really see what happens after that, but it looks like it keeps growing.
It looks like it's growing, but the amount it's growing is increasing or decreasing. Right here? So this is plus 390.
D.
This is 358. So it is increasing, but the rate at which it's increasing seems to be decreasing. Well, let's talk about situation. What's a force acting on the cannonball as soon as it leaves? Gravity's slowing it down, right? What about the numbers of the two tables comparatively do you notice? So we notice this one's slowing down and the other one's linear, right? The other one keep going though. Right? So things were similar early on. Anything exactly the same?
The start.
Yeah, Troy, the starting point. They both started 10 feet off the ground. Okay. They're both increasing, but the rate at which this one was increasing was slowing down as it went on. So let's talk about number 3, writing the equation. It's going to be as easy as this. I'm going to ask you some questions about the situation. You're going to answer them. Okay, the distance it goes. Well, where did it start? 10. So it's starting at 10. How fast is it going?
406.
Per second, right? And then what is gravity doing to it? Up or down? Down 16 t squared for gravity.
Oh!
Do you see how I said we have it all there? Yeah, Ivy? If it's an emergency, make sure you sign out after Maddie gets back. Okay. So again, let's go over these three things. It starts at 10. It's going 406 feet per second. And gravity is pulling it down by 16t squared. We saw the 16t squared yesterday throwing the rock off the roof, right? You guys remember this? Yeah? Why? Who can tell me why it has to be subtract? Zeph?
Because that's what gravity is because since it is up in the sky,
Yeah.
it is being pulled down.
It's being pulled down. We can also check a point. So let's check input 1. At 1 second, if I put it in this function, I'm at 406 plus 10, 416. At 1 second, gravity's going to do minus 16 to it. That's why we've got the 400. Yeah, it's pretty cool. We're going to look at a new cannonball next. And I'm going to, don't get computers out, but everybody has to do the technology piece because you need to practice this. Like, you're going to have to do it on your homework tonight, the technology piece. So, when you get there, let's set it up. Don't open your computers yet. We have this new function. All right? This new function is distance equals 50 plus 312t minus 16t squared. The first thing you're going to do with your partner is define what the 50, 312t, and negative 16t squared mean in context.
Easy.
Then you're going to go to Decimal's graphing calculator, type in the function, and make sure you set your window to this. You're going to be able to set your window to that by, it's a wrench in the upper right-hand corner. And you'll be able to set your domain and range. You'll see it when you get to Decimal's graphing calculator. Then you'll describe, get the maximum, estimate when it hits the ground, and then we'll talk about domain and range. So work time for this other cannonball. So, talking about what these numbers mean, I want to focus on the 50 first. Who can tell me what the 50 is in context? What is the 50 in context? Yeah. The starting point. So this cannon is 50 feet in the air, right? That's what the 50 is, our starting point, shooting from 50. What's the 312T? Zep?
That is the height change.
Yeah. It's like the velocity. It's going 312 feet per second. So faster or slower than the last one? Slower. Starting higher, going slower. And what is the negative 16t squared in context? Sean?
The applied gravity.
This is gravity, right? The force of gravity. Cool. So make sure you're tightening up right now, getting that Decimal's graphing calculator to do what you want. And then we're going to talk about the shape, the maximum, when it hits the ground, and we're going to get some words down for those things as well, some fancy words. So going to the computer and the Decimal's graphing calculator. I need to get the right function here. The starting point was 50, okay? And it was going how fast? 312 feet per second, and the same gravity. So you can see, like, I can't see much. You can see I can't see much here, right? It just looks like a line. So we're going to change the window to what it was suggested. It wanted 0 for X. It wanted, what, 0 to 25?
Yeah.
And for Y, it wanted 0 to 2,000.
0 to 2,000. Domain and range, am I right?
So now that we have this here, what shape do we have? A parabola. Okay. So I'd explain the shape. The next question is, what is the maximum height? Who can, like, or how high does it go? Who can, like, tell me where I could maybe find that? Zeph?
If you click on the top right,
Like right here? This has a name.
yeah, I was gonna say
The vertex.
It's called the vertex, okay? I am going to click on it in a moment, but I got to get rid of the writing. So make sure you wrote down the shape is a parabola, Soldier Boy's favorite. And at that point right here, the maximum, it can also be a minimum. Not in this case. Minimum. But the vertex is always going to be the maximum or the minimum. All right? Well, our parabola could be like this.
So it's the real number.
Vertex still, yeah. All right. So let me get rid of my overlay. So check this out. One nice thing about Decimals graphing calculator is I can click and hover, and what this ordered pair says is at 9 3/4 seconds, the cannonball is 1,571 feet high. So when we say the max, we would only reference the output. So 1,571 feet is the max. Everybody good with how I did that? Now this next thing is when it hits the ground. And that's going to happen right over here. Everybody see that? It's kind of right against right there. So this actually also has a special name. It is the X-Intercept, but it's also called a zero when the output is zero. Yeah, actually with parabolas we'll call them zeros, and we're going to talk about that in just a second. So this is called one of the zeros. Why is there only one zero, do you think, in this context?
Probably because
Yeah, Zeph.
Because y would be within the positive root.
Yeah, it doesn't make sense to go negative on the x because the least time is 0 time. And at 0 time, how high is our cannon? 50 feet. So this theoretical parabola has a 0 right here as well. But in context, are we ever going to be at negative 0.159 seconds? No. So there are 2 zeros to the parabola, but in context, there's only going to be 1 0. Does that make sense what I'm saying? What happens if this cannon started on the ground, right here? How many zeros? 2. Because 0, 0 would make sense in context then. But this cannon doesn't start on the ground, it starts at 50. Which means in context 1 0, the parabola still does have 2 zeros. Talking about the domain and range. What should our domain be? In context. Yeah, so it can be 0, and what's the most it could be? What's this value over here? 19 point. Was it 7.5? I can't click on it and write on it. 659. I can't click it and write the center. Okay, and then for the range, what's the lowest it is? 0 when it hits the ground, and what's the highest it goes again? Was it 1579? Can someone just click it for me quick? Okay, so there's my domain and range because context matters for this, right? When it hits the ground, it's done. It's not going below the ground. I get a cannonball might go into the ground a little bit, but the highest it goes would be the highest for all possible y values. So this would be, again, domain and range. And the other new words are vertex and zeros. In context, though, just 1 0 in this case. Awesome.